just a question. Is it increasing? Is it decreasing? Dot, 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 dot. So, right off the bat, what did he say? He said, I asked for the bounds on this. He says it's bounded below by 0. Right? What is bounded below? Bounded below means a sequence is bounded below if there is a number, doesn't matter what you call it, I'll call it little m, so that a sub n is bigger than or equal to m for all n equals 1, 2, 3, dot, dot, dot. In other words, every term of the sequence is bigger than or equal to this number. So what's a number that every term in the sequence is bigger than or equal to? 0, right? They're all positive. So 0 is a lower bound for this sequence. Now, is negative 1 a lower bound for the sequence?
Yeah, it could be.
It is, right? It's every term of the sequence is bigger than 0. It's certainly bigger than negative 1. So how many lower bounds are there?
Negative infinite?
Yeah, as many as you want, right? Because any negative number is a lower bound. So this is a lower bound for this also. Hence the word greatest lower bound. Of all the lower bounds, what's the biggest one? 0. Because anything bigger than 0 is not a lower bound, right? If I picked a number m in here, like pi over 10,000, that's a really small number, really close to 0, right? Is it smaller than every one of those? No, take 1 over a billion. 1 over a billion is in my sequence, right? And it's going to be smaller than that number, isn't it? So, no positive number can be a lower bound. So this number is the greatest lower bound. The greatest lower bound is the number that is the largest of all the lower bounds.
So 0 is probably the most common.
Depends on what the sequence is, right? Depends on what the sequence is. Not every sequence is bounded at all, because all I have to do is let it be n squared from n equals 1 to infinity. Is that sequence bounded below? Right? What does that sequence look like? 1, 4, 9, 16, 25, dot, 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 right? What's a lower bound? What's a lower bound for this sequence? 0 is a lower bound, right? Is it the greatest lower bound? No. The greatest lower bound because everything in the sequence is greater than or equal to 1, and no number bigger than 1 is a lower bound. So, and this sequence is not bounded above, right? Right? It goes on, it gets larger and larger and larger. So now, in the notes, I ask you to prove certain things, like prove something is bounded. So if I want to prove that this sequence is bounded, suppose I want to prove it's bounded below. Well, my claim is that, it's not a very interesting problem to work, but my claim is that negative 1 is a lower bound. Not the greatest lower bound, right? I'll put negative 3 is a lower bound. That's my claim. So I have to show that 1 over n is greater than or equal to -3 for all n equals 1, 2, ... Right? That's what it means to be a lower bound. That the sequence is always bigger than or equal to that. Well, I'm going to do the scratch work off to the side. 1 over n is greater than or equal to -3, so 1 is greater than or equal to -3n. So n, I got to flip the sign, right? Greater than or equal to -1/3. I just worked backwards to solve for n. And I remember to switch the sign when I divided by the negative number. So, well, since n is equal to 1, 2, ... then n is greater than or equal to -1/3. So 3n is greater than or equal to -1. So -3n is less than or equal to 1. So n is less than or equal to, wait, what am I trying to get to? Trying to get 1 over n by itself. So -3 is less than or equal to 1 over n. So 1 over n is greater than or equal to -3. For all n equals 1, 2, 3. Pause there. What's the difference between my scratch work over there and the proof? I just reversed it, right? I have to reverse it because, like we talked about before, you can start with something that's false, play with it, and get something that's true. That doesn't make this statement true just because I started with a false statement and ended up with a true statement. You've got to be able to go the other way. So when you do this playing off to the side, you have to make sure that everything is reversible. So the proof, this is not part of the proof, this was just my scratch work. My proof, I have to show that this is always bigger than or equal to -3. Well, n is a positive integer, so it's definitely equal to -1/3. Therefore, this is true, therefore this is true, therefore this is true, therefore 1 over n is always greater than or equal to -3. Now I've proved that -3 is a lower bound for this sequence. Questions on those steps? So other things ask you to prove like that this is decreasing, right? This one's clearly decreasing. What do you have to do? You'd have to prove that 1 over n plus 1 was always less than this to prove that it was decreasing, right? You'd have to prove that. Now, the way you're going to do it is you're going to do your scratch work and you're going to reverse it. Okay, stay off the streets. I'll see you on Friday. We'll put up more